Imagine this. You're staring up at the night sky, mesmerized by the glow of countless stars. But what if I told you that some of those stars no longer exist? That the light reaching your eyes is a message from a distant past, perhaps 1,000 years ago, perhaps 1,000,000. Every time you look into space, you are not just seeing stars, planets, and galaxies. You are witnessing echoes of history, a cosmic time capsule delivering secrets from an ancient universe. But how is this possible? How do telescopes act as time machines, allowing us to see the past with our very own eyes? And just how far back can we go? Could we ever witness the birth of the universe itself? Before we embark on this journey, let me ask you something. Have you ever wondered what it would be like to be part of an expedition, one that uncovers the deepest mysteries of the cosmos? Right now, Cosmic Whispers is just beginning, and your support means everything. Every great journey starts with a few brave explorers. If you enjoy unraveling the wonders of space, hit subscribe. It's free and it helps us grow this community together. Now, let's begin with something you may not have thought about before. Everything you see, even in your everyday life, is actually in the past. When you glance at your phone, the light from its screen takes time, an almost imperceptible fraction of a second, to reach your eyes. The same goes for the world around you. Light doesn't travel instantly. It moves at a finite speed, nearly 6 trillion miles per year. But what does that mean for space? Let's start close to home. The moon. When you look up at that familiar silver face in the night sky, you're actually seeing it as it was 1 1/3 seconds ago. That's because the moon is about 239,000 miles away, and it takes light that long to travel to Earth. Not too mind-blowing yet, right? But now let's move farther. Mars, depending on its orbit, is anywhere between 34 million and 250 million miles away. Light from Mars takes between 3 and 20 minutes to reach us. Imagine an astronaut waving at you from the Martian surface. You wouldn't see them wave in real time. You'd see it minutes after it happened. If something catastrophic happened, on Mars we wouldn't know until minutes later. And that's just within our own solar system. Let's take a bigger leap. Our closest neighboring star, Proxima Centauri. It's over 25 trillion miles away. The light we see from Proxima Centauri today actually left the star 4 years ago. If Proxima Centauri were to suddenly disappear right now, we wouldn't realize it until 4 years had passed. Already, our cosmic time machine is starting to show us a significant slice of history. But this is only the beginning. Now, what happens when we push beyond our immediate cosmic neighborhood? Consider the Andromeda Galaxy, the closest major galaxy to our Milky Way. It's a staggering 2.5 million light-years away. That means the light reaching us today from Andromeda left its stars when early humans were just beginning to use stone tools. If a civilization exists there, and they had powerful enough telescopes, they wouldn't see us as we are now. They'd be looking at Earth during the dawn of humanity. This is the incredible reality of looking deep into space. The farther we look, the older the light, and that's where telescopes come in, our ultimate cosmic time machines. With the naked eye, we can see a fraction of the universe's past, but with telescopes, we can push further and further back, peering into the history of the cosmos itself. But how does this work? The answer lies in something called redshift. You see, our universe isn't just sitting still, it's expanding. The farther away a galaxy is, the faster it's moving away from us, and as it moves, the light it emits stretches out, shifting from visible light into longer, redder wavelengths, a phenomenon known as redshift. The most distant galaxies are so redshifted that their light isn't even visible to the human eye anymore. This is where telescopes like James Webb come in. Unlike the Hubble Space Telescope, which primarily captures visible light, Webb is an infrared telescope. It's specifically designed to see light that has been stretched beyond human perception. This means it can reveal objects so far away, their light has been traveling for billions of years. We are quite literally looking at the universe as it was shortly after the Big Bang. But here's the real mind-bending part. The deeper we look, the closer we get to the very edge of the observable universe. Theoretically, if we had a telescope, powerful enough, we could see all the way back to the moment the first light appeared in the cosmos. But there's a catch, an invisible wall, a cosmic boundary that no telescope can see beyond. Before we dive into that mystery, let's take a step back and understand how telescopes evolved over time. How did we go from Galileo's rudimentary lenses to powerful observatories capable of peering across billions of years? The answer to that lies in the next part of our journey. Let's take a journey back in time, not through space but through human history. Picture this. It's the year 1609, and an Italian scientist named Galileo Galilei is standing in the dim glow of a candle peering through a strange contraption, a long tube fitted with curved glass. He tilts it toward the night sky, focusing on the bright crescent of the moon. But what he sees is not the smooth, perfect sphere the philosophers of his time had imagined. Instead, he sees craters, vast, jagged landscapes of light and shadow. This moment changes everything. For the first time in human history, someone has used a telescope not just to look across the land, but to reach across space itself. Galileo's telescope was crude by today's standards. It magnified the sky only about 20 times, and yet with this simple device, he shattered centuries of belief. He saw the moons of Jupiter orbiting their planet, evidence that not everything revolved around the Earth. He observed the phases of Venus, proving it orbited the Sun, not us. What Galileo had done was more than just make discoveries. He had given humanity a new way to see the universe. Now imagine if Galileo could see what we see today. His telescope, rudimentary as it was, had already turned the night sky into a portal to the past. But modern telescopes? They've transformed that portal into a time machine beyond anything he could have dreamed. So how did we get from Galileo's simple tube of glass to telescopes capable of peering billions of light years into the past? The answer lies in centuries of innovation, driven by one fundamental goal: to see more, to see farther, to see deeper. For much of history, telescopes were limited by one thing: Earth's atmosphere. When you look up at the stars, they seem to twinkle, flickering in brightness. It's beautiful, but it's also a problem. That twinkle is caused by turbulence in our atmosphere, distorting the light before it even reaches us. For astronomers, this is like trying to read a book through the surface of a rippling pond. Then came a game changer: space telescopes. In 1990, NASA launched the Hubble Space Telescope, positioning it above Earth's atmosphere, where nothing could interfere with its view. And what it saw was breathtaking. Hubble showed us the universe with unprecedented clarity, nebulae bursting with color, galaxies colliding in slow-motion cosmic ballets, the deep field images revealing thousands of galaxies in what seemed like empty space. But even Hubble had its limits. You see, Hubble could only capture visible and ultraviolet light, the kind of light our eyes are accustomed to. But the universe doesn't just speak in visible light. Much of its oldest, most distant secrets are hidden in infrared, a form of light that has been stretched by billions of years of cosmic expansion. And to see in infrared, we needed something even more powerful than Hubble. Enter the James Webb Space Telescope. Launched in 2021, Webb is a masterpiece of engineering. Its golden mirrors are designed to capture the faintest, most ancient light in the universe. Unlike Hubble, which orbits Earth, Webb orbits the Sun at a location called the second Lagrange point, nearly 1 million miles away. Out there, shielded from the Sun's heat, it can see the universe in exquisite detail. And what has Webb found? The discoveries have been nothing short of revolutionary. Galaxies that formed just a few 100 million years after the Big Bang. Stars being born in swirling nurseries of dust. Even the atmospheric compositions of distant exoplanets, revealing the chemical fingerprints of alien worlds. But here's the real question: just how far back can we see? Could we witness the birth of the very first stars, the formation of the first galaxies? Could we, if we had a telescope powerful enough, see the instant the universe began? There's a limit to how far light can travel. A cosmic horizon beyond which no telescope, no matter how advanced, can ever see. To understand why, we have to go back, not just billions, but 13.8 billion years, to the moment of the Big Bang itself. But before we reach the edge of the observable universe, we must first understand what lies just beyond the limits of our sight, a time before stars, before galaxies, before light itself. And that's where our journey will take us next. The deeper we peer into space, the further back in time we travel. But if we keep going, pushing our cosmic time machine to its absolute limit, we'll eventually reach a point where something extraordinary happens. A wall of darkness, an era so ancient that no telescope, not even the mighty James Webb, can see beyond it. This is the cosmic dark age, a time before the first stars ignited, before galaxies took shape. A time when the universe itself was blind. To understand this invisible boundary, we have to go back 13.8 billion years to the very beginning, the moment of the Big Bang. In an instant, the universe was born, an unfathomable explosion of energy, space, and time itself. But despite what the name suggests, the Big Bang wasn't really an explosion in space, it was an expansion of space. The entire universe, everything we know, was once compressed into an infinitesimally small, incredibly hot point, a singularity. And then, boom. Expansion began, faster than the speed of light. But here's the strange part. In those first few moments, there was no light, not in the way we understand it. The universe was a chaotic storm of energy, an opaque soup of subatomic particles. Protons, neutrons, and electrons swirled in a cosmic dance, too hot to form atoms. Any photons, particles of light, were immediately scattered, unable to travel freely. Then, around 380,000 years after the Big Bang, everything changed. The universe cooled just enough for atoms to form, mainly hydrogen, and helium. And when that happened, light was finally free to travel. This first light is known as the cosmic microwave background radiation, the oldest light in the universe. It's not from stars or galaxies. It's a literal afterglow of creation itself, a faint whisper from the birth of time. But after this burst of light, something strange happened. The universe went dark again. This was the cosmic dark age. For millions of years there were no stars, no galaxies, just vast empty clouds of hydrogen, stretched across space like an unlit canvas. Nothing was emitting visible light. If we had a telescope that could somehow transport us to this era, we would see it was nothing, a cold, silent void. So how did the first light return? How did the cosmos awaken? Slowly, over millions of years, gravity began its delicate work. Tiny ripples in the density of the universe, left over from the Big Bang, caused clouds of hydrogen to clump together, forming the first stars. And these stars were unlike anything we see today. They were giants, hundreds of times the mass. Give our sun, burning impossibly hot, blazing with an intensity that reshaped the universe. These first stars, known as population 3 stars, were cosmic pioneers. They didn't just light up the darkness, they changed it. Their powerful radiation stripped electrons from surrounding atoms in a process called ionization, making the universe transparent once more. This was the second great transformation of the cosmos, what astronomers call the epoch of reionization. But here's the challenge. These first stars were so massive that they burned through their fuel in just a few million years, collapsing into black holes or exploding in some of the most violent supernova the universe has ever seen. They lived fast and died young, leaving behind almost no trace. And this is where the James Webb Space Telescope comes in. Scientists believe Webb is powerful enough to detect the faintest whispers of these ancient giants, their light stretched across time, buried in the deepest layers of cosmic history. If Webb succeeds, it won't just be looking at the past, it will be looking at the beginning of light itself. But even Webb has limits. No telescope, no matter how advanced, can see past the cosmic dark age. That boundary, the moment before the first stars, remains a mystery. And beyond it lies something even more elusive. The first few seconds after the Big Bang, an era where the laws of physics themselves may have been different. Could we ever go even further back? Could we somehow see the Big Bang itself? The answer might not lie in telescopes at all, but in something even more fundamental. And that's where our journey will take us next. So far, we've traveled back billions of years, witnessing the birth of stars, the formation of galaxies, and the end of the cosmic dark age. But now, we stand at the edge of the visible universe. Beyond this point, no telescope, not even the James Webb Space Telescope, can see. Light itself cannot take us further, but What if there's another way? If telescopes are our cosmic time machines, then light is the film reel they use to replay the past. But light, despite being the fastest thing in the universe, has limits. There's a point beyond which it simply cannot reach us, a cosmic horizon, a curtain drawn across the first moments of time. That's because before 380,000 years after the Big Bang, the universe was a dense, opaque plasma, impenetrable to light. But while photons were trapped, something else was already escaping, something that might let us see even further back. Gravitational waves. Unlike light, gravitational waves don't interact with matter in the same way. They ripple through space-time itself, carrying information from the most violent and ancient events in the universe. When two black holes collide, when neutron stars crash together, when entire galaxies merge, these events send ripples across the fabric of reality. And here's the key. If gravitational waves existed in the first moments of the Big Bang, they might still be traveling through the universe today, carrying the very first whispers of creation. Detecting them, however, is no small feat. In 2015, the Laser Interferometer, Gravitational Wave Observatory, LIGO, made history by detecting the faintest stretching and squeezing of space-time caused by merging black holes over 1 billion light-years away. It was like sensing a ripple in a pond the size of the Earth. But even LIGO is just scratching the surface. Future detectors, like the proposed Laser Interferometer Space Antenna, LISA, will be positioned in space, far more sensitive, capable of picking up ripples that could lead us all the way back to the moment of the Big Bang itself. If we could read those primordial gravitational waves, we wouldn't just be looking at the first stars, we'd be seeing the very structure of space-time being woven. We might uncover evidence of cosmic inflation, the theory that suggests the universe expanded faster than the speed of light in its first fraction of a second. We might even find clues to one of the greatest mysteries in physics: what happened before the Big Bang? Some theories suggest our universe was born from the collapse of a previous one. Others propose that we exist in a vast multiverse, where new universes are constantly being born. Could gravitational waves carry echoes from other universes? Could they reveal dimensions beyond the three we know? If so, they wouldn't just be time machines to the past. They would be windows into everything. For now, we stand at the frontier of the unknown. Telescopes like James Webb have already rewritten cosmic history, revealing galaxies that formed earlier than we ever thought possible. But there is still more to see, more to uncover. New telescopes, like the upcoming Nancy Grace Roman Space Telescope, will push even further. The next generation of observatories, perhaps quantum telescopes or even telescopes using black holes themselves as cosmic lenses, could take us deeper into the past than we ever imagined. And perhaps one day we won't just see the past, we'll understand it in ways we never thought possible. The universe is a story written in light and shadow, gravity and time, and as long as we keep looking, as long as we keep asking, we will always be explorers of the greatest mystery of all. And if you enjoyed this journey through time and space, don't forget to like, share, and comment. What do you think lies beyond the edge of the observable universe? Let us know in the comments. Because every great discovery begins with a question, and yours might be the next to change the way we see the cosmos.